Okay, let's talk about dilations, because dilations are super important. I actually really like dilations. I think they're fun. The key operation for dilation, super important, is multiplication. Okay, that is very, very, very important. It's multiplication. Dilations result in a similar figure. And think about it, if you're similar to someone else, you have some qualities that are the same, but you're not exactly the same. So dilations result in similar figures which are proportional because they have the same shape but different sizes. Okay, because dilations, remember, are getting bigger and smaller. So sometime part of dilations is we have to create ratios of corresponding size and set them equal to each other. And remember, there's lots of different ways that you can write this. Okay, so for example, we've got side AB, and it corresponds to DE. And you see these little angle markings? This is going to help you determine that. Okay, so what about EF? What goes with EF? Hopefully you see that BC, right? So BC. Notice here we have the smaller triangle on top, the larger on bottom. And so that's really important too, that we're being consistent. AC, you see, corresponds with DF, right? Okay, so that's just kind of going over corresponding sides and how we can set up ratios and proportions. When we're looking at the coordinate plane, remember dilations have a scale factor, represented by the variable k. Also really important, we talked about the pre-image. The pre-image is the original or the before, our original image or our starting image. It's what we start with. The image, and it has, notice how it has that little prime marking right there. Image is the new, what you end with. And remember, it's marked with that prime notation, like A prime. Okay, enlargements make the pre-image bigger, right? And its scale factor is always greater than 1. So enlargements. If it's a reduction, then our pre-image gets smaller, and its scale factor is between 0 and 1. So it would look something like this, and I forgot to do that. Okay? And remember, so the algebraic representation for dilations is xy, and then we do k times x and k times y. An example, remember that k is going to be your scale factor. That is your number. And so that's an example of what it might look like with numbers in it. Super important. Dilations, not only are they important, but they're super easy too.